Hello everyone, welcome to In 5 Minutes. In this video clip, we will discuss next problem on nodal analysis. In the video clip before this one, we have discussed the concept of supernode. In this particular question, we have to determine the current through 1 ohm resistance. 1 ohm resistance is here and we are going to use nodal analysis. Now, in the nodal analysis, the very first step is always to mark the nodes, and then we will decide how to write KCL equations at every node. So you can see there are various nodes in this particular circuit. Starting from here, this is my first node because you can see it has 3 branches coming out of it. Second will be this node. This is also a valid node because there are 3 branches coming out of this node again, and this will be my third node with 3 branches. And this bottom line is the fourth node, and we always take this bottom node as the ground or the reference node. So we'll continue to do that. With that, I'm left out with 3 nodes. Let me define voltages at all the 3 nodes as V1, V2 and V3. Now, to get the current through 1 ohm resistance, because 1 ohm is connected between V1 and V2 along with this battery, I will require the values of V1 and V2. We can get V1, V2 only if I write KCL equations at node 1, node 2 and node 3. So we will solve for V1, V2 and V3 simultaneously. So let's do that one by one. Now, this is the circuit in which we have to apply some important points that we have discussed before. Point number 1. You can see that you can't write KCL at node 1 because there is a 10 volts battery between this node and the ground. Whenever such is the case, you can't define current through this branch, and hence you can't write KCL at this particular node. Because there is a voltage source between the node and the ground, as we have discussed in one of the previous questions, we get directly the value of V1. And once again, you can see that negative polarity is towards the ground and positive polarity is connected to the V1, and hence we can write V1 equal to 10 volts. So that becomes my first solution directly. We got the value of V1. Let us now go to V2 and then node V3. Now, even before you define the outgoing currents, you have to carefully observe and see that no doubt there is 8 ohm resistance between V2 and V3. But there is one more branch starting from V2 which has a 12 volts battery going towards V3. I can very well define current in this branch, current in this branch. For example, current in this branch of 8 ohm resistance will be V2 minus V3 upon 8. But once again, the same problem. I can't define current through this 12 volts branch because for that I must need some series resistance with 12 volts. So because of the same conclusion that we have made earlier, that because there is no series resistance with the battery and because there's a voltage source between the 2 nodes, none of them is the ground node this time. And hence we form something called a supernode. So once again, the supernode comes into picture. There's a supernode between V2 and V3. So in such a case, we don't write individual KCL equations. Although we will define the currents quickly, but we will have to write KCL at this supernode, which becomes a combination of V2 and V3. So let's first define the currents. With respect to V2, one outgoing current is from V2 towards V1. Now please remember that whenever you have formed a supernode, whatever branches you have between V2 and V3, you never write any current expressions in those branches. There is a branch of 12 volts battery and there is a branch of 8 ohm resistance. If this 8 ohm resistance was not there, then we would have definitely not defined current through 12 volts. That is something we already know. We are not going to define current through 12 volts battery because we cannot. But what about current through 8 ohm? Even though I can define it as V2 minus V3 by 8, we will not consider it because 8 ohm comes between V2 and V3. I repeat, whatever branch comes inside the supernode, whatever branch comes between the 2 nodes which are part of the supernode, we do not define currents between them. So we discard this branch, we discard this branch. We now go to V3, and the moment I go to V3, there's only one branch now. Let me define outgoing current through this branch. So this simplifies a lot. There are only 2 currents that I have to consider. These 2 currents I will not consider because they come between the 2 nodes which are forming the supernode.